Hello, um, welcome to my office, or my toy room, as my girlfriend likes to call it. I'm Ed Oldham. I'm a data engineer at Advancing Analytics. I've been with the company just under a year, and prior to joining AI, I'd never used Databricks before, so it's still pretty new to me. I've managed to gain a few certifications in the last year, so hopefully I've managed to learn something. But before I was here, I mostly had a history in Microsoft and AWS tech stacks. So I've seen lots of different stuff. So let's get on with it. So this is the agenda for today. We're going to talk about data lakehouses. So it's going to be a pretty introductory session. So if you have used Databricks or Spark before, might not be for you. So yeah, don't worry about leaving now if you want to. But yeah, we're going to talk about what is a data lakehouse, a bit about data lakes and data warehouses. We're going to talk about Apache Spark and Delta Lake. We're going to talk about medallion architecture, and we're going to talk about all the layers of medallion architecture and what might go on with your data at those different layers. And then at the end, we're going to have a demo in Databricks Community Edition, which is a completely free thing that anybody can sign up to. So if you want to try it out, you will be able to. And that demo is just going to go over how to sort of load data into Databricks and how to just promote it for all the layers of the lakehouse. So yeah, let's get on with it. So data lakehouses are more popular than ever. Microsoft Fabric is about to be released into general availability. So Microsoft have obviously shown massive confidence in this technology, and Databricks is massively well performing company. So it's doing really well at the moment, and lots of people are starting to use this technology now. So I'm mostly going to talk today from a Databricks perspective, just because that's what I know, it's what I've used for the last year while I've been learning about data lakehouses. But it's important to point out that lots of this stuff can be applied to any data lakehouse. So lots of it applies to Microsoft Fabric as well, and different things also. So really simply, what is a data lakehouse? Take a data lake and a data warehouse and you kind of smash them together. But really, it's a data lake with some extra stuff added on, which makes it better. And it's features from a data warehouse, really, which have been added to a data lake. And the idea of this is to take the positives of both while addressing at least some of the negatives, but hopefully all of them. And the thing that really makes a lakehouse possible is a storage framework. So I'm going to talk about one of those frameworks today called Delta Lake. There's a couple of different ones that have been made by different people, like Apache Iceberg and Apache Hoodie, and they are all frameworks which make it possible to turn data lakes into data lake houses if you use them. Okay. So we talk about a data lake and the pros of it. You can store any sort of data, structured, unstructured, audio, video, anything. It's really quick to get that data into it. You will have lower costs relative to a data lakehouse. You can store massive amounts of data very cheaply. It's very accessible when you've got your data in a data lake, and it's easy to use advanced algorithms, machine learning, things like that. But if we talk about some of the cons of a data lake, doing it on premises is very difficult. There are tools which exist, like Hadoop or Splunk, but data lakes are built for the cloud, really. So you'll probably have quite a steep learning curve with having to use new tools and services with the data lake, and that's going to require training and upskilling. If you're already working with the data warehouse, migration can be tricky. It might take careful planning, and you need to have your strategy locked down. So data lakes aren't read optimized. So if you're querying from a data lake, it can be comparatively slow. Governance can be really difficult. You might not have control over who can see what data. And if you want to do BI, you probably need the data warehouse as well. So data warehouse pros, I mean, I'm sure most people on the call have used a data warehouse before. They know a lot of these, but basically they've been around for ages. They work really well. They've been really optimized. They're flexible in terms of being able to do it on-prem, in the cloud, or hybrid. It's really easy to do that governance and control who can see what, and they're very structured, and that structure can make it easy to do relational queries and things like that. But if we talk about data warehouse cons, storage costs can be comparatively high, especially once you start getting into that big data sort of levels. It takes a lot of time to develop components of a data warehouse. You know, you need the code for every part of it, and that might take a long time to do. Often you end up having limited source data because of that problem of it being expensive to have data in it. So you might not want to add data into your data warehouse unless you're absolutely sure that it's going to be used for something, and that can limit the amount of data that you have to query or just play around with. Data warehouses aren't really built for big data, and now the amount of data that's being collected by companies is absolutely rocketing. So are they up for the challenge of that? And it can be quite complicated to change over. If you've got new fields in your source data, and you want to add them into your data warehouse, it can be quite tricky to do. You might have to reprocess data, add empty fields, things like that, things that are really annoying jobs for a data engineer. And finally, there's quite a potential for data distortion. When your data relies on preload cleansing, if there's errors in that, it means that they can stay in your data forever, and your data will be distorted. So this is the data lakehouse. This is at least what it's trying to be. It's still having that structure of a data warehouse, that table structure, that relational structure. It's easy to govern the data and who has access to what. It's familiar because it's still using tables and views and things that we're used to, and SQL. It's fast. There is a star on that because kind of depends how you set things up, and if you set things up badly, it won't be that fast potentially. But it can be extremely fast for very large amounts of data. You still got that flexibility though of a data lake in being able to deal with structured and unstructured data, and it's still comparatively cheap to have massive amounts of data in. And also it's incredibly scalable. When your size of data keeps increasing, you can easily add more until you're getting into sort of billions and trillions of rows territory. So why would you want to use Databricks over a modern cloud data warehouse? A lot of these people on the screen have addressed a lot of these problems with a data warehouse when it comes to not being able to have all of the data in it if you want. But really, why you might want to use Databricks over one of these is that it's a unified platform, which means that you've got your data engineering, data science, and data analytics all there together. And when we talk about data science and machine learning with Databricks, the great thing is that you've got support for running models in production, really good support because Databricks owns MLflow, which is a really powerful tool for machine learning and having production models, which is really kind of better than a lot of competitors at the moment, in my opinion. So also we've got Apache Spark and Delta Lake, which we're going to learn a bit more about in a sec. But that is kind of Apache Spark, what gives us really good performance and lets us process large amounts of data. And Delta Lake is kind of what gives us some of those data warehouse features to our data lake. Finally, with Databricks, you can spin it up in Microsoft. You can move it to AWS or Google if you want. You're not locked into any vendor, and it's easy to change over. So why would you not want to use Databricks? So it can be very complex to migrate, and you will have to learn a lot of new stuff, which can be scary. And I think one of the big things for me was that realizing a lot of things I knew about how to optimize SQL and stuff didn't necessarily work anymore. So you have to consider that. And finally, I've put it can be a train compared to a bicycle. And what I mean by that is that trains can be very fast and powerful and hold a lot of people and goods and move them very quickly and stuff like that. But if you want to go to the shop at the end of the road, sometimes a bicycle is better than a train. So if you're dealing with a really small amount of data and you don't need all of this parallel processing and stuff like that, then maybe go with the bicycle and not Databricks. So what is Apache Spark? All you really need to take away from this is that it's open source, which means anybody can contribute to the project. And now there's tons of massive companies that are using this, and lots of them are contributing to the project. So it's getting better all the time, and it's much better than something that's just been developed by one company, kind of in isolation. The other thing is that it's distributed, which basically means that it's calculating stuff in parallel and processing your data in parallel. So if you look at that diagram, you will have different amounts of worker nodes compared based on how big your Databricks cluster is, or your Spark cluster if you're not using Databricks. And that will mean you have a certain amount of executors and task slots. And when you do a job, the data will be split amongst all the task slots, and then put back together at the end. So it can just break things down, do it at the same time, and then put it back together again. And that's how it manages to do stuff so quick. So what's Delta Lake? So Delta Lake is not a file format, it's a storage framework. It uses existing file formats like Parquet and JSON. Parquet is a columnar storage format, which basically means it's just very compressed, and the files are a lot smaller for bigger amounts of data. And then on top of that, we also have a JSON transaction log, which helps with our versioning and lots of the features of Delta Lake. So yeah, it's Delta Lake is Parquet, but better. It's got a few more bells and whistles, a few more things going on. What does Delta Lake give us? So thanks to that transaction log, we have time travel, the ability to select data and say, as of a certain time, which is just so powerful if you're used to just using SQL in a data warehouse. We've got a transaction log, which helps with our troubleshooting and things like that. We've got the ability to do schema evolution. So when I talked before about adding new fields in, so much easier with Delta Lake. Again, it's open source, so there's loads of people contributing to the project and making it better. We've got really good data compaction, and that just means that you've got more data in a smaller sized file. Support for multiple languages like Python, Scala, and SQL that we know and love. And then we've got ACID transactions. And this is probably the biggest thing that gives us a feature of a data warehouse to a data lake. So ACID is ACID, which is atomic, consistent, isolated, and durable. And what this means is atomic basically means that your transaction would either succeed or fail. It can't kind of get halfway through and then leave your database in a weird state. It's consistent, so the database will be left in a consistent state before and after your query. It won't be, you won't have a data type change that you didn't mean to, things like that. Isolated means that transactions don't affect each other, and durable means that data is written, once it's written, it won't be lost. And yeah, that's what kind of gives the classic data warehouse experience to a data lake. So medallion architecture, also known as multi-hop. First thing, it's not actually really an architecture at all. It doesn't really involve data structures in a classic way or infrastructure. It's just about organizing your data and having it in different zones or possibly layers, you might like to call them. And so the classic layers are bronze, silver, and gold. You can have any names for your layers you want. I would probably say don't use those layer names. I think it's better to have something that tells you more about the data in each layer, or it tells you more about your business. So it's not a hard and fast rule that you have to be called bronze, silver, and gold. It's also not a hard and fast rule that you have to have 3 layers. I would always recommend having at least one more layer, which we'll talk about in a bit. But yeah, you can kind of do whatever you want with this and change it to your sort of business case and your use case. So yeah, what we mean by those layers, bronze, silver, and gold, the metals are obviously getting more precious as we go through those layers. And what that denotes is having more structure and more validation to our data as we get through the layers. And really important thing about this is that this is probably very like what you've already seen. If you've used a data warehouse and you've got a kind of something like a raw staging and ODS or EDW, it's very similar to that. So this is not by any means a reinvention of the wheel. It's kind of tried and tested in data warehousing. And yeah, it's nothing particularly new or mind-blowing. So bronze layer, this will be the first ingestion into the system. It will be the complete history of your data, hopefully. So your data will be unvalidated and raw. You might want to add a file name and ingestion date, which will probably help you out later on with troubleshooting and searching for duplicates and things like that. But that's the only kind of change that you would make to the data, apart from potentially changing the file type to Delta. I would suggest this in bronze layer because it gives you the ability to do that time travel and stuff, and have that transaction log. So yeah, that's what I would recommend you do. So yeah, and when you're loading data into bronze, you can use a combination of batch and streaming. We'll kind of talk about that a bit in the demo. And it's really easy, at least with Databricks, to do that. So real easy to do real-time streaming if you want to, which is really powerful. So moving into silver, we want to filter, clean, and augment the data. We want to handle any missing data. We might need to refill it or maybe discard it if it's the fact that it's missing makes it useless. We want to deduplicate. You might want to apply validation rules. So this would be things like not having any nulls, making sure that your data is unique, making sure that your data is of the correct type. You might want to have logical checks, which would be things to do with business rules. So it might be something like, does an order have an order date? For a country field, it might be that the field is a real country and that it's spelled correctly. And so you also might want to enrich your data here a bit with reference data. So that could be things like swapping out a country code or a state code for a full name, or using a postcode to get a full address or something like that. And so in Silver, depending on your data, you either want to append, or you might use a merge to just load new data or changes to your data. So it's no longer necessarily going to be that complete history, but it's just the new things that you care about. So moving up to the gold layer, and here is where you want to kind of have your data model. Might be a star schema. You might want to do something completely different, like third normal form. The gold layer is probably the best place to apply that, although again, there's not a hard and fast rule about that. You can have a star schema in every layer if you want, but generally with clients, we see that they will have a star schema in their gold layer if they're using one. So yeah, we want to have those business aggregates, which might be things like monthly or yearly sales tables. We might have queries that show how much customers have spent in a certain time frame. You might have different aggregations for different lines of business, anything really. That's, yeah, sky's the limit. So, and yeah, this is where, you know, you've got your model and you're joining tables together, and that will be the queries that you're using and the basis for visualizations. If you're using something like Power BI or Tableau. If you're using Tableau, I wouldn't recommend using a star schema. So other layers, I'd always recommend having a landing layer, and what that will let you do is just have some abstraction between your Lakehouse and your source systems. You have somewhere that if you don't have access to the source systems, that people can drop that data into an area, and then you can load it from there. In your landing layer, you can just have your data in its source format. You might want to convert it to Parquet if it's more compressed. But yeah, you can have it in JSON or something like that if that's how it's coming out of a source system, and then convert it to Delta in Bronze. So you might have use cases for other layers as well. Mentioned a couple. I talked about Tableau just then, and if you wanted to have a star schema, you might have another layer after that, which kind of normalizes the data again for use by Tableau. You might have different presentation layers for different audiences. So yeah, you can just totally convert this to your sort of business case and what you need to do with it. Nothing is kind of that. This is a strict rule of you must do this. It's very flexible. So at AA, we generally use the landing, raw, base, and curated, unless customers want to have their own conventions. But this is just to say, call it what you want. Yeah, it's totally flexible to do what you want to do. I kind of think raw, base, and curated is pretty good, and raw, stage, and curated is pretty good because it's kind of telling you a bit more about what the data is at each layer. Okay, moving on to the demo section. So I've done this in front of people twice, and both times it has gone wrong. So we'll see what happens today. So yeah, as I said at the beginning, this is Databricks Community Edition. It's totally free to use. You can sign up and get an account. I really wish I had known about this a year ago when I was interested in learning about Databricks, because it's a really good tool. And so the only caveat with this is that you pretty much get the smallest compute available, and then your compute will always shut itself down after 2 hours, and then you have to make a new one. But as just a starting place to start learning about Databricks, it's really good. So what we're going to do in this demo, we are going to get some JSON files that I've made, which are just really simple files which have got a bit of information about different textbooks that can help you learn about Spark and data warehousing, data engineering related things. We're just going to load that into a lakehouse, have tables at different layers, and do some really simple kind of transformations to stuff at different layers, just to show you what you can do, and maybe get your imagination going a bit. So yes, this is completely free. All of the files that I'm using in this, I have available for anyone to download at the end if you want to. So yeah, you can try this yourself for free if you want. So that. Right, so what we're going to do is upload some files to the Databricks file system. So this is not what you would do in production. In production, you would kind of have your files in Amazon S3 or Microsoft Blob Storage or something like that. But just for a simple kind of example, I'm just putting them in the Databricks' own file system. So we've got file 1, 2, and 3 there. Let's click next on that. I'll just kick that off because it takes a while to run. So yeah, what we've done is just loaded 3 files to the file system there. In this first cell, I've just set some things up. So where it says create database, Databricks use database and schema pretty much interchangeably. So think of it as a schema in a data warehouse or a database. And then all I'm doing is just setting up some variables which I'm going to use a bit later on, like file paths and table names and stuff like that. So this is running now. You can see down here that it's a streaming job. But let's go through the code and just try and understand what I've done. So firstly, we're going to read a stream. That's just going to tell it that you want it to do a streaming job. This bit here will basically designate that you want to use autoloader to load this. I'm telling it the format of the files here, and we're giving it a location that it's going to store the schema in. So what it will do is look through all the files, work out what the schema is, and then store that schema, which can then be used later. Here I'm telling it that in my JSON files, the JSON for each record is across multiple lines, and this was a really tricky bit when I was learning this and trying to get it to work, which would trip me up. So if your data is across multiple lines for each record, you need to make sure that that is selected as true. So what am I doing with the data in my files? Well, I'm selecting star, I'm selecting everything, and then I am adding a source file name, which is just a function which is available to me, and I'm adding a load time just to make it a bit easier for myself. So then I'm saying I want you to write that stream somewhere. This is a really good thing about autoloader, this checkpoint location. And what it means is it's going to write what files it's loaded. So if I load some files and then put some more files in, which I'm going to show in a minute, and then load them, it's not going to load any duplicates. I don't have to move anything to a completed folder or anything like that. Just have all my files in the same directory, and it's only going to load what it hasn't already loaded, which is really powerful. So the trigger, I'm just telling it to load all the files that are available right now. And then I'm specifying a table that I want it to load into. So yeah, we've run that. That one worked. The kind of thing to say about the trigger as well is that if I didn't use this trigger, this is really easy to just have as a real-time job. You can just get it to start. Then your trigger will be like, you can get it to trigger every 5 seconds, every 2 minutes, whatever you want, every second. And then that will just turn into a real-time stream of data. So one of the great things about Spark and Delta and Databricks is that you can still just use pretty much classic SQL. There's a few more bells and whistles. A few things are done a bit differently, like how you kind of use variables and stuff. But if you use this %SQL magic command, it's %% SQL in Microsoft Fabric, which I've found very tricky at first. You can just do classic SQL. So yeah, just looking at what we have loaded into the bronze table so far here. So we've got file 1, file 2, file 3. Yeah, we've got our processing time. All looks pretty good. We've got this kind of nested author field which we need to sort out, but all looking good. And so yeah, if you want to do that same command using PySpark, you can, using the spark.sql, which is very useful if you just want to kind of inject some SQL in something. It kind of gives you this horrible output. So you can make it look a bit nicer by doing this, using this show command, .show. But if you just want to have it like the SQL way, which is what I like, you can use this display command. And that will just give you exactly the same as what we had up here. So we want to move into silver now. So what are we going to do? What are we going to do different from the bronze layer? Well, we're going to say we're going to read this table in bronze. We're going to select everything. We want to do a transformation on it because we want to sort out that author field. So what we can do is create another field which will read that JSON. We need to give it a schema for it. But then once we've done that, we can use this dot notation to get anything out of that JSON field just from the key. So we'll add the first name and last name field as well. And then we'll drop that original nested field and that field that we've created to sort it out. And so we'll just be left with a nice first name and last name field. So again, we're going to write that stream. We're now going to write it to our silver table. Again, we just want to do all of the files that are available now. And again, we've got our checkpoint, so we can just load files or load data which hasn't been loaded yet if we run it again. So let's kick that one off. Should have done that before because it takes a bit of time to run. And yeah, it does take a bit of time to run these jobs, even though it's a really small amount of data, just because it's got to spin everything up. And this is kind of what I mean about you might not want to do this with a really small amount of data. So let's just use our display command again to have a look at what we've done. Yeah, good. we've sorted out that first name and last name. But really, you can do any sort of transformation you want. You can duplicate it here if you want. So now to move into gold, I'm going to create a view on the data in silver. Now, the reason I'm doing this is so I can use SQL to do my sort of aggregation and joining and stuff like that. I still think it's the best way of kind of working with data and doing complex transformations and business logic and things like that. So this kind of method lets you do that. So let's create our silver view. And what I'm creating here is just a really, really the most basic aggregation I can, really. I'm not joining any tables together because I've only got one table, so I'm just counting the amount of books that are published in each year. So let's just quickly check the output of that before we create it as a gold table. And that looks good. So now we're just going to create our gold table. And give it another check. Cool, looking good. Okay, so now we are at the bit which normally goes wrong. So what I'm going to do now is just load another file, and then I'm just going to demonstrate that it is just going to load this new file. It's not going to load the stuff that I've already loaded. So scroll back up to the top. We're just using the same exact code again. And now it's just going to load all the files which are available now, which because of the checkpoint is going to know is just the new file. It's worked. Okay, so let's just check that one. Yeah, we've got file 4 in there. So that's brilliant. We will load up silver now. We don't need to create our view again. We just need to query it. So let's create our gold table again. This is obviously kind of a full load example. You can easily do incremental loads and stuff like that. It just takes a bit more kind of doing, but I just wanted to make this as simple as possible. Right, let's have a look. Yeah, so we've got some new data in there now. Doesn't look like anything's been duplicated either, so that's good. Cool. So yeah, that's pretty much it. Thanks for coming. Thanks for listening. If you want to get in touch, talk about anything, my email's there, my LinkedIn. This video is a YouTube video which has just been done by our CTO this week. talking about medallion architecture and a bit more about how we use it at AA. If you want to make a lake house, you want somebody to help you, please get in touch with us. And yeah, I've got the link to the slides there, link to demo files if you want to have a play with the demo and see if you can get it to work on Community Edition. These links aren't in the slides which are on SlideShare. So if you want the links, take a screenshot of this or something now. And yeah, finally, we've got a blog at Advancing Analytics, which has got a lot of stuff about how to kind of take this to the next level, how to do slowly changing dimensions, how to do a SQL merge and things like that if you want to do an incremental load. So yeah, if you're interested, please have a look at that as well. And yeah, just thanks for listening.